Alright, now we'll check the transducer calibration to make sure that they're reading the appropriate way. Go to Monitor Transducer. We've entered in the calibration data for all 4 of these. These are the 3 for the direct shear machine and the 1 for the consolidation apparatus. Channel 9, 10, 11 are the horizontal force and vertical displacement transducers for the direct shear machine. So for the horizontal one, as we mentioned, we want this to read positive with the piston going in. So as we move the piston in, we're reading positive values on the monitor transducer screen, which is very good. So it's reading the correct way. The force, we can just verify the force. You can take it off and put a known weight on the force transducer to verify that it's reading right, but it's reading positive going in, which means the polarity is correct. And now the last one is the interesting one, and that's the consolidation of the vertical transducer that's going to be used to measure the consolidation of the sample. Now, this one's reading positive going in as well, but the problem is that we want this to read positive with the piston going out. We're going to put this on top of the sample, put a weight on the sample, and then it will consolidate moving downward. So this requires the opposite polarity. Also, the same for this consolidation transducer here. We want it to read positive going down, not up. So we're going to have to put a negative polarity on both of those transducers. So if we click OK at the bottom right, go back to Configure, Transducers, go to channel 11, which is the vertical transducer for the direct shear machine, and they have positive slopes right now. Go to the box number 4, polarity, the bright orange button. Click that until the slopes are negative. Then click the apply button beneath the serial number. And what that does is that if you click on the bottom, the channel set, channel 11 now has negative slopes. We'll do the same for channel 13, which is our consolidation transducer. Click that until you have negative slopes. Then hit apply, and then you'll see the negative slopes have been applied here to the channel set. And then when you click OK, that data will be saved to the calibration files that are on the computer. Okay? So now what we want to do is we've verified that our transducers are reading appropriately. Now the next step is to generate a machine. We already have the triaxial machines generated, but let's go ahead and set up a new machine. Click the new Set Up New Machine button. Enter in the name for the new machine. We'll call this Direct Shear. Click OK. And then click on the Direct Shear here on the left side. And then you want to go over just to the right of it, select Test Type. Click that button. We're not using British Standard, we're using the ASTM standard. Then click the drop menu, and this shows you which tests the customer has purchased, the modules that they've purchased. We're going to do shear strength by direct shear for this one. Then click OK, and what that does, it automatically brings up which transducers are required for that test, and we need to fill in which channel on the logger is we want associated with each one. The horizontal displacement is channel 9, the force is channel 10, and the vertical is channel 11. And then we hit apply, and that automatically brings in all the calibration data that we just verified and inputted and verified within the system. Now we want to go over to default machine parameters, and we can enter in the box area and the lever ratio. The box area may or may not change depending on which size boxes you have. You may want to calculate that. I'll leave that as 0 for now, and we'll calculate it later. But then you have a lever ratio. That lever ratio is going to be a 10 to 1 for this type of machine. It's all 10 to 1. We don't have a hanger or a lever weight. That's for more of a calibration if you have an issue with counterbalances. You can also, there's a frame deformation correction, which ASTM does have a section on that where you can correct the deformation of the frame based upon the weights that are applied. We won't go into that now. We'll just save default, hit apply, then click OK. Do you want to save changes? Yes. Takes us out of there. And now if we go to new test, we have a shear test ready for testing. Let's return to main menu and also generate a machine for the consolidation. Set up new machine. We'll call this Consol. This only has 13 characters, maximum. Then click on the console up here, select test type, ASTM, drop-down menu, one-dimensional consolidation test, OK. And as we know, the consolidation only requires one deformation transducer. We know that that's channel 13. We can go to default machine parameters. We can put a ring number, a ring diameter, a weight, a height, and all of that in here if you'd like. Or you can leave them blank and fill them in as you test each one. The consolidation machine, you'll notice, has 3 holes where you can apply the vertical or the load or the normal load onto the sample. This allows you to have a wider range of weights or stresses or loads to put on the sample depending on what stresses you require for your testing. What this is a 9-to-1, 10-to-1, and 11-to-1 ratio for your weight application. You can calculate the amount of stress that's on that depending on which ratio and how much weight you apply. Obviously taking into consideration the diameter of your sample, the surface area of your sample. So you can put that on here as default, or you can leave them blank and fill them in as you go along if you do change those. You also have the frame correction for this type of machine as well. We can put this a ring 1, lever weight ratio 10 for now, and hit OK. It's telling me the ring and the lever parameters must be greater than 0. So let's go ahead and just leave them at 0 now, and we'll make them 0. We'll fill them in as we test each time. But you can certainly, if you know you're going to test each one at the same way, you can certainly input those as the default values. Then hit apply, and that brings in the calibration information, and hit OK, and it asks you if you want to save it, say yes. And now when we click new test, we have a consolidation machine on there as well. So we're going to now test a direct shear sample on the direct shear machine. Ready to go with that. So click direct shear, select the machine for testing. What we can do is do something called load existing sample. Instead of filling out these 4 or more cells, we can load existing sample. Open up all the way to the INI file and hit open. And it automatically fills in any information if the samples are identical to something you've already tested. We can do that. We're at test, job number, sample number. But the only issue with that is you notice that the specimen does not allow you to do A, even though it's a different type of test. But we can go ahead and cancel that and start over. That was just to show you if you do want to continue on and do a sample B, and we'll show that again as well. But we'll do test, job 1, sample 1, specimen A. And that's okay because it's a direct shear versus the triaxial. So click OK, it takes us back to the test monitoring screen, which we've discussed. Start test stage, test initialization. Sample weight in grams. Here's the issue though, we want to test in imperial units. So go back to configure, system settings, imperial, OK. Now we have to go to monitor test to find our test, because if we go to new test, it's in use now, because we've initialized the information. So go to monitor test, initialize, sample weight, sample height, dry or submerged. We have a water bath that you can place with water, and then the box area. But before we fill out this information, let's focus on the shear box itself and the sample that we'll generate, which is over here on the table. I have it completely taken apart now, where we have the bottom half of the shear box. We have the top half that sits on top. We have the bottom plate that has grooves in it, that fits into the little pins that are sticking out of the bottom plate. It fits in one direction. And then it comes with 3 porous stones, 3 brass porous stones. Typically for 1/4-inch samples in this type of shear box, we use 2 at the bottom and 1 at the top. That allows us to have a 3/4-inch sample with the shear plane between the top and bottom half of the shear box to be right through the center. Then we have the top loading plate, and we have the 2 screws that connect the top and bottom during consolidation, but we must remember to remove these before shearing, or you'll shear the pins and not your sample. Very high load, but it's also very expensive to replace. Okay. Software does remind you to remove those before